Hey everybody! Wow, that was weird. All right. Today we're going to keep talking about our linear stuff, and we are going to talk about how to graph something in slope-intercept form. So yesterday we talked a lot about writing an equation in slope-intercept form, how to find that slope, how to find that y-intercept sometimes. Today we're going to kind of assume that they give us stuff. All right. So let's say I have this graph. And I am going to give you an equation in slope-intercept form. I think this video should be kind of short because I think you guys will pick this up no problem, hopefully. And I know that you should have done this before, but you probably didn't, but that's okay. So let's say my equation is y equals 1/3 x minus 4. Y equals 1/3 x minus 4. All right. The first thing we're going to do is think about, well, what's the slope, what's the y-intercept? What's nice is since it's in slope-intercept form, it tells me this is my slope, this is my y-intercept. So my m here is 1/3. It's rising 1 and running 3. My y-intercept, be careful with the minus sign, is -4. So if I want to graph this line to see what it looks like, you're always going to start with your y-intercept here. I always tell my kids, begin at B, right? B is for begin. So my initial value is -4. So on the y-axis, I'm going to find -4, and I'm going to put a point, because I know that point is on my line, because my y-intercept is -4. All right? Then from there, my slope is 1/3. So that means from this point I started at, we're going to rise 1 and run 3. And remember that when we're running, we're always going to go to the right. So rise 1, run 3. Do it again. Rise 1, run 3. Let's see if I can fit one more. Rise 1, 1, 2. Let's assume 3 is over here. Bam. There you go. So after you have a couple points, draw as straight a line as you can. And that is the line y equals 1/3 x minus 4. That's all you got to do. Not too shabby, right? So we just want to talk about a couple example things that we need to talk about, and then I'm going to let you go. So let's do a different one. Let's say we did y equals 3x. Let's just do y equals 3x. All right, so again, the first thing you're going to do is think, what's my slope, what's my y-intercept? My slope here, the coefficient of x, whatever's in front of x, is 3. So that's going to go up 3, rise 3, run 1. Because if we wrote 3 as a fraction, it's 3 over 1, right? So 3 is up 3 over 1. My y-intercept here, there is no y-intercept. That's kind of weird. That means that my y-intercept must be 0. Because, think of it this way, I could rewrite this as y equals 3x plus 0. We just never would need to write plus 0, right? So this one, we're going to start at 0, 0, right at the origin. And this one's going to go rise 3, run 1. Rise 3, run 1. And if you want to, you can always work backwards to get a point, right? So like somewhere you had to rise 3 and run 1 to get here. So if you rose 3 and ran 1 from here, 1, 2, 3, over 1. You can see that you can work backwards on your graph too. And there is your line, y equals 3x. Awesome. Okay, what else do you need to know? Well, there's some special kind of graphs that you probably want to know about. What if my line has 0 slope, right? And what if the slope is 0? We talked about that the other day. That's a horizontal line. if it has a slope of 0, right? Well, what would the equation look like if I was told to graph that line? Because we probably won't see y equals 0x plus 4. But think about what's really happening here. If slope is 0, 0 times x is 0. 0 plus 4 is 4. So if you see a line that just says y equals a number, right? Any number, just y equals, that is a horizontal line. That's the line with the slope of 0. So I'm just going to find 4 everywhere that y is 4. 1, 2, 3, 4. And right here y would be 4. Right here y would be 4. Right, this is the point 3, 4. Notice that everywhere on this horizontal line, hopefully you draw better than me, would have a slope of 0. So if you see y equals a number, that's just going to be a horizontal line, slope is 0. Now the other one, the other special one with a slope that's undefined, I think that one's kind of hard. Because how would you write that in slope-intercept form, right? Like it doesn't make any sense even. Because our slope's something over 0. So what we're going to see if you're going to graph this thing is instead of y equals a number, that's horizontal, you're going to see x equals a number. And whatever x equals, x would equal anything in a vertical line. So this is going to be the line of a slope. Let's not do -1 because it's too close to the origin. Let's do -5. 1, 2, 3, 4, 5. This line has an x of -5. This is an x of -5, -5, -5. Right? This line is going to be my vertical line. And notice again, it does not look like slope-intercept form because it's not y equals some stuff. Well, that should give you another red flag that this is a special one. Right? It doesn't look like slope-intercept form. Why is it x equals something? Oh, because that's a vertical line with a slope that's undefined. All right? So those are the special ones. That's pretty much how you graph. I think you guys will be okay. If your y-intercept is a fraction, which can happen, you just try your best, right? So you might not know that this is 2/3, but I'm going to guess that's 2/3, right? So let's say I had y equals x plus 2/3. Well, I'm going to guess that 2/3 is about there on my graph. And then I'm going to use my slope. So if there's no number in front of x, we know that's really just 1. So it's going to go up 1 over 1. Well, up 1 is going to be like at the same spot on this spot. So, about there. And I go over 1. Up 1, about there, over 1. Up 1, about there, over 1. So it's not the greatest of things when we have to graph these. It's a little bit better if you have graph paper because, as you can see from my graph on my smartboard or on my whiteboard, it's maybe not the best increments, right? But graph paper is. So that's helpful. But even if you have fractions, they're still not going to be great. Yeah. So try that out on the problems that you have for today. Let me know if you have any problems graphing and we can work from there. All right? See you later.